my name is Nako Nakatsuka. I'm a fourth year chemistry PhD student at UCLA, and today I'll be helping you guys out by going over some general chemistry concepts. And good luck with the course. Just as a reminder of some common names, methyl ethyl propyl is just the simple alkyl groups, but then we also have things like iso, sec, and tert that comes before the alkyl group. So when you see iso, that's when the carbon that's attached to whatever the parent chain is bonded to only one other carbon. So basically, it's a primary carbon. In this case, this carbon that's bonded to whatever parent chain there is bonded to two other carbons. So this is secondary. And finally, this carbon is bonded to three other carbons, so it's tertiary. And so that's how you get the names iso, sec, and tert. Also, for pentanes and above, we also have the name neo as a prefix. And an example of this is when you have some kind of parent chain attached to a carbon that has three methyl groups attached. And this is only for pentane and up. And so a good thing to know is isobutane, which is very commonly seen, and also neopentane. So now I also wanted to talk about cycloalkanes very briefly. So cycloalkanes are basically cyclic hydrocarbons. So they have the formula CnH2n. And so some examples of them are this triangular structure, which is cyclopropane. And this is C3H6, since the carbons are at each of these corners, and so we have two hydrogens per corner. So we have C3H6. Another example is this square, which is cyclobutane. And this is C4H8. Some of the most common cycloalkanes are the cyclopentanes and the cyclohexanes. When we talk about cyclohexanes, you'll often see them in the chair conformation, but we'll go over the chair conformation in more detail later on. So when we name cycloalkanes, basically if you just have one substituent, so in this case, let's do this. This is a 1, 2, 3, 4, 5 carbon ring, so it's going to end with cyclopentane, but it only has one substituent, which is this guy right here. This is an isopropyl. Why is it an isopropyl? Because this carbon is only bonded to one other carbon. And so it's iso, like I showed you guys right above here. And so in this case, since there's only one substituent, I actually don't have to number this cyclic carbon. And so it's just going to be isopropyl cyclopentane. On the other hand, if I had two substituents, so in this case, let's say I have a methyl group right here and then an ethyl group right here. So I have one guy here and another guy here. The central cyclic structure is 1, 2, 3, 4, 5, 6 carbons, so it's going to end with cyclohexane. So now I actually have to number them to indicate where the two different substituents are. And so since this is an ethyl group and this is a methyl group, we know that the ethyl will come before based on the alphabetizing. And so I'm going to number this as 1, 2, 3, 4, 5, 6. So I end up with 1 ethyl, 4 methyl, cyclohexane. So you follow the same exact rules as what I went over based on the substituents, but when you just have one, you don't have to number it. When you have more than one, you always have to indicate where it is on the cyclic structure.